Lesson 3 reading, page 226 in Earth in Space, Heavy Thoughts. Do you ever wonder why you jump up, you always come back down? Or do you ever wonder why the moon keeps circling around Earth rather than drifting off into space? Throughout history, people have wondered about these things. Now we know that a property of the universe called gravity is responsible. If you jump up, Earth's gravity will pull you back down. Your gravity also pulls Earth towards you. The same thing happens between the sun and the planets, and between all the planets and their moons. Gravity guides the movements of everything on Earth and all the objects in the sky. Newton's apple. According to a well-known story, a 23-year-old English scientist named Isaac Newton was sitting under an apple tree one afternoon in 1666 when an apple hit him on the head. Newton began thinking about the force that pulled the apple from the tree. Newton concluded that the force we know as gravity must be an invisible force, like the one you can feel when you place a magnet near a metal object, although gravity is not as strong as electromagnetic forces. He also determined that gravity affects apples falling from trees and holds planets and moons in their orbits. Page 227. Newton's law of inertia. Newton wrote two famous laws about gravity, the law of inertia and the law of universal gravitation. The law of inertia says that a body in motion tends to travel in a straight line unless it is disturbed by an unbalanced force. The law of inertia explains why you don't keep rising when you jump up in the air. The unbalanced force of gravity disturbs your motion and pulls you back down. The law of inertia governs the motion of the planets and moons. If they weren't affected by gravity, they would travel in straight lines and leave the solar system. The sun's gravity holds all the planets in orbit around it, and each planet's gravity captures and holds its moons in orbit. What is an unbalanced force? If two individual forces are of equal magnitude, size, and opposite direction, then the forces are balanced. Think of the marble you held in your hand during Inquiry 15.1. One force, the Earth's gravitational pull, exerts a downward force on the marble. The other force, your hand, pulls upward on the marble. If the forces acting on the marble are balanced, as a result, the marble's motion does not slow down or speed up. But if the two forces are not balanced, the marble will change its speed or direction. If you let go of the marble, the unbalanced force of gravity disturbs the marble's motion, and the marble falls into the box. Unbalanced forces cause objects to accelerate, change their speed or direction. Page 228. Newton's law of universal gravitation. From his experimental results, Newton formulated the law of universal gravitation, which states that any two objects in the universe have gravity and will attract each other. Just how much these objects attract each other depends on two things: the mass of each object and the distance between the objects. The more mass a star like our sun has, and the closer a planet is to that star, the greater the star's ability to hold the planet in its orbit. Mercury is a perfect example. Planets with a lot of mass can probably hold more moons in their orbit. Jupiter is a good example. Mutual attraction. An object with a large amount of mass can exert a huge gravitational pull even on objects that are quite distant and massive. The sun's gravitational pull is so enormous that it easily hangs onto Jupiter, which weighs 2.5 times as much as all the other planets combined. The sun also exerts a gravitational hold over Pluto. But more amazingly, tiny Pluto exerts a gravitational pull on the sun, even though they are more than 4.5 billion kilometers apart. Like the end of a lasso that circles around the head of a cowboy, an orbiting planet is tied to the sun by gravity. However, the farther a planet is from the sun, the more slowly it travels into its orbit. The closer a planet is to the sun, the faster it travels in its orbit. Mercury, the planet closest to the sun, travels at about 48 kilometers per second. But Pluto is quite a different story. Look at Table 15.2, orbital velocity of planets, and compare the orbital velocity of the planets. Do you notice patterns in the data? If so, what are they? The attraction between two objects decreases as the distance between them increases. The Sun's pull on distant Pluto is much less than its pull on nearby Mercury. As a result, Pluto orbits the Sun at a much slower speed. Newton and other scientists made important discoveries that describe how gravity works. These discoveries demonstrate that objects on Earth operate under the same principles as objects in space. Newton's work will influence planetary science for centuries. The end.